Good afternoon. So possibly I'm giving the only talk today about the teaching, like how to train the next generation IoT engineers. Yeah. So University of Navarra is a private university in Spain. So as a professor there, our first priority is education. And the second is actually research. Okay, so we always put teaching and education first. As you know, or maybe in the other talks today, you have heard about the MIoT, which is a new low power, wide area IoT technology. So we have been working on this for a while, and we have developed our training plan for the IoT engineers around this technology. And here today, I'm going to show how we are doing this. And also another reason for me to share this talk is because, like we believe, the people are the most important part if we want a sustainable development of the IoT. So if the university, we can train good IoT engineers, then for the company side or for the industry side, it would be much easier. Okay? So that's why we'd like to share our work, and then maybe we can get some feedback from your side that like how we can do better in our future teaching or education. Yeah. So here's the outline. For those who are not quite familiar with the university and our school, I'm going to quickly present University of Navarra and the Tecnun School of Engineering. By the way, the Tecnun School is located in San Sebastian, a very beautiful city. And then for the next, we're going to talk about the available MIoT resources that we have collected and that we have used to train the IoT engineers. And after that, we'll present the Tecnun programs, like which courses and which programs we have been using these technologies to train the engineers, and then also some outcome. And after that, we're going to present our team, also a quick glance of our research. As we know in university, for sure we do research, but the second priority here in the private university. Okay. Yeah, so these are some figures of the university. These are not the latest figures, but some figures from the last year. We have here. Some space from here. Okay, sorry.
Standing here.
Okay. Yeah, okay. So for the numbers, we have 13,000 students from the last year. The alumni, like 143,000 from all over the world. This university, we have nearly 30% international students and 7 campuses, with 4 campuses in Spain and the other 3 campuses in North America, Latin America, and another one in Munich. And for the rankings, it doesn't reveal everything, but somehow a number. In Spain, we have the foundation CYD, second best. And for THE, this we believe is an important indicator, is the employability ranking. It means like how the employers are happy with our students. So we are ranked 45. And then QS ranking 249, more or less. So these are the data from the last year. And for the engineering school, so it's smaller. We have 1,500 students from last year. Among them, 1,000 undergraduate students. And we also have nearly 400 master and 120 PhDs. For the engineering school, 20% are international students. Nearly 50% are from the local area. Gipuzkoa is a province where the engineering school locates. And the others from the rest part of the Spain. This engineering school is not a very big one, I would say that. The scalability is a bit small. We have 4 engineerings. Okay, not like some big university, they might have, I don't know how many engineering program, but we only have 4. And I'm affiliated with the electrical and electronic engineering, which is responsible for training or for teaching IoT technologies to the rest of the engineering school. So by the way, our IoT courses is not only limited to telecommunication engineering or electronics, but to all the engineering school. Because we believe the other engineer, like the mechanical engineer, they'll also need IoT someday in their work. So just the teaching levels are different. So we're teaching IoT to all the students in the school. Okay, here's our program. Like the undergraduate, master, and the PhD program in Tecnun, the first year is just a common year for students to learn these mathematics, physics, circuit, etc. These fundamental courses. For second year, there's a common year for the industrial-related branches. Like those 4 degrees, they're going to study these same courses. The others, more or less, have their own study plan. And then after the 4-year training, the last one will be the final degree project. And for master, we have these masters and now, like industrial engineering, and then telecommunication engineering, biomedical engineering, big data science, data analysis engineering, and the technological innovation. Some degrees are located in Madrid. Some are located in San Sebastian. Yeah, but even though they are in Madrid, some of the IoT courses is the professor from our department to go and teach them. And then we have one PhD program, which is the PhD in applied engineering. It's one for the whole school. Yeah, the other programs are the like hybrid or international diplomas. Okay, so for MIoT, we have adopted MIoT in some of the courses. For sure that we cannot put it in all the courses, but we selected some. The courses that I would like to highlight are the itineraries and the LETO courses for the second and third year, respectively. These courses actually is not purely taught by professors from the university, but we are collaborating with the companies. Like the topic actually is given by the company. So each year we are going to make a call, like contact to the companies that are in touch with our university and asking, okay, if you're interested to propose a project for our third year students, the project can be somehow related to your company demand or not. But up to them, they can propose, okay, we think this topic might be interesting. Then we can arrange, like publish this topic to our students to see if someone would be interested to work on this project. Of course, the project is not very complicated, considering that they are just second year and third year students. You cannot give a problem that cannot be solved by a mature engineer to them. Yeah, but this is how these courses are organized. Then in one of these courses, it's called Computer Science Itinerary. We were introducing MLT here. And the others are the final degree project. Some students have conducted did their final degree project with the MIoT. And the others are the master courses in telecommunication engineering and data analysis engineering. In these 2 courses, we are also introducing MIoT technology for the students to have a deep understanding of how a sensor works and how the data transmitted and how they can get the data, etc. Okay, and then some master project. These are the program that we are adopting this technology. Okay, so for the next, what MIoT resources we have been using in Tecnun? Here I made a list. It's more or less all the resources that we have. By the way, Tecnun, we are one of the earliest associated member of MIoT. I guess we joined maybe in 2021. Like the Aliens was founded in 2020, maybe. So just 1 year after that, we are a very early member. And we found the good thing is like, if you go to the MIoT Aliens, you can find some resources. It provides the early stage evaluation kit, such as the ABA gateway. It's not very professional, but it's just for evaluation. So for people to get a quick setup and get a quick understanding of this technology. And for Hoffer developed that. With that, then we adopted this one. And inside is actually a Raspberry Pi plus a narrowband software-defined radio. And you can even open it and show the student this is the hardware inside. And for the endpoint, LTE have developed the MakerBoard, the MIoT endpoint. And with this hardware, if you go to the software part, the second one, M3B Helper, is the corresponding software. So if you get this hardware, you can get the software, and then you can have a MIoT endpoint sensor node. So that's what we are also trying to do for our students. Because for this one, LTE, the MIoT part is based on a commercial module. So for students of the mechanical engineering or industrial engineering, it's okay because they don't directly work on the telecommunication stack. So it's enough for them. But for some telecommunication students, their purpose is to develop the stack in the future. So just an application layer code, it may not be enough for them. So then that's why we can have used the first one, like the TS, Telegram Splitting, UMB, the library. This one, it has 4 implementation of the mioty stack, the network stack. So it's not just an application-oriented source, but the lower layer sources, the Mac layer and the coding, etc. You can get it there. And there are other resources developed like mioty Go. I guess it's a product from L'Oreal, also for educational purposes. It was released last year, but we have not yet started using this one. And the last one is the STM32. This one is actually a development from a third-party company. It's not affiliated with the MIT Alliance, but someone migrated the first open source project to STM32. Then you can develop a sensor not only based on Arduino, but with STM32 now. Okay. And on the right side, you get all these documents, the technical overview, the sensor development information, and system architecture, and also the security, etc. Then this can be the theoretical study material for the students. Okay, so these are the resources that we are using. Okay, so the first step is to start to get the students prepared so they can work on this technology. Then we introduced in the computer science itinerary, we teach the basic knowledge to the students, like what is the Internet of Things, what is the Arduino ecosystem, so the student can play it with, and then what is the Python programming and how to write their code, and then how to design the user interface. So we are covering these 4 modules in this course. So after that, the students will be quite ready for programming and develop something. And yeah, here I selected one project. Okay, it's just one project developed by one group. We have many others. Like each group has 2 to 3 students. So this one, the student, they have developed this Arduino, let's say, simplified boat. And they put the sensors. And they put this boat in the water. And the sensors will collect the parameters of the water, like the water quality, the temperature, etc. And in front, there's the obstacle detector, automatically like turns if there's some obstacle in front. And then all the data transmitted to the cloud system, like think this week. Also later, they can develop their own interface. So there's the one video on YouTube, but unfortunately, we cannot show it here today. If you're interested, maybe you can go and watch the video by yourself. So this is the preparation part. After the preparation, we move to the 3rd-year course, which is the LETO. The LETO, we got some topics for the environment monitoring of the building environment, and also some other projects from the MIT City Science Lab to monitor the data of the city. And then to support these ideas, we also, these one are the things that we have presented earlier. And the one thing is we have introduced the L'Oreal, the cloud system in our teaching system. Because L'Oreal, there's I don't know, maybe a trial version. If you connect less than 30 nodes, it's free. You know, for universities, it's better free, okay? Yeah. So as we don't have that many students, so okay, we think, okay, L'Oreal, we can use the free version, and then to give the students an idea how they can use cloud computing. Then with the mioty endpoint, the gateway, and they can connect the data to the L'Oreal cloud system. And then from L'Oreal, the student can write their own code to get the data back for analysis and visualization. Yeah, so this is the key architecture. Yeah, but by the way, if L'Oreal could sponsor this course, it would be better for the future. Yeah, and then these are the documents that we share with students. Like for this development, this document will be helpful. Then we teach them a little bit of the knowledge. Then they are going to read the document by themselves and develop the project. This is how this course works. And in this course, I selected these 3 projects. One is for building monitoring. The students just install these sensors in Tecnun. Like the sensors are developed by themselves with the M3Q board and plot some CO2 sensor, and then the other parameters are temperature, humidity, etc. And then through the gateway to L'Oreal, then some interface there. Yeah, so this is the work from the students. But please do not criticize too much because this is work from the 3rd-year undergraduate. Okay, not from us, just 3rd-year undergraduate students. Yeah. And the other one is like some students wanted to monitor the parking slot of the university. So sometimes, yeah, like in the morning, they need to drive around the university to find the parking slot. So they were thinking, OK, why don't we develop a system like that? Then they developed this interface and the sensors with magnetic sensing to detect if there's a car or not. And this one is an exam automatic evaluator. Like this is a mimicked answer sheet with the big black part. And then based on that, the student try to say, OK, we can mark the answers at the black part. And then they developed this with the Legos, this kind of machine to automatically read this answer sheet and calculate the marks for the professors. Yeah, this one is also controlled with the M3Q board. Yeah, so these are the selected 3 projects. And the other one is for the final degree project. So the first one is developed by a student from the telecommunication engineering. The target is for ultra-remote area LP1, like some areas there's no power, there's no terrestrial network. Then how to build the IoT, how to collect the data. Then he came up with the idea. And here what he used is he used this MIoT for the wide area data collection. And the central part is the box. So they developed this box, and you can see the ABA gateway is integrated inside to collect for data collection. And use solar and the battery to provide the power, and use the Starlink to send all the data through the satellite and back to the L'Oreal again, the cloud system. And then from L'Oreal, you can get the data directly to ThingsBoard. So basically, this is the work from one undergraduate student graduation project. Yeah, the final year project. OK. And then these two other projects, one from electronics engineering, the other from industrial electronics engineering. The thing is that one, the M3B, is kind of expensive. Yeah, because it's new, kind of expensive. So we were thinking, OK, maybe if we want to a larger scale, we can develop the board by ourselves. And based on the materials provided by MIoT Alice. Then we posted this topic. Some student is interested in this work, and she developed our own MIoT endpoint. Well, not developed, but like kind of produced. Okay, it's not for commercial. It's allowed not for commercial, but education purposes. Yeah, this one is based on the MCU Artemega 328. And then on top of that, the green part, there's the external RF communication module. So, and the software is that one. Then we tested everything, and it worked fine. And another student developed more, because this processor is 8-bit processor. So the computational capability is low. Then we developed another one, is this one, based on STM32. Yes, and the stack we use is that one. So 2 versions of MIoT endpoint were downloaded here. Yeah, so we have 2 MIoT endpoints now. And this is the gateway that they have developed and installed on the top of our building. And then they can collect all the data. Yeah, so these are 2 other final year projects. And then at the master level, we have 2 courses. One is the data analytics in Industry 4.0. So there we teach how to collect the data from the industrial environment. Then I ask the students to develop a system like this. Then they can have this portable Raspberry Pi and touch screen to collect data for the local visualization. And the other one is for telecommunication master. We now have 1 part-time internship. So for telecommunication students, from my point of view, I always want to torture them. OK, this just the system integration is not enough. I always try to torture them, give them a challenging topic. So the topic for the partner for the internship is to, OK, we have the stack now. We can receive the data, but the energy performance there for the rooms, for energy performance. We can further reduce the energy consumption. And in the end, we can make it a completely energy harvesting node. That's our target, but we don't know how far we can go, like to totally remove the battery based on MIoT sensor node. So now we have students working on this. Yeah. Okay, here's our teams. Basically, Hector is the one. I must highlight that Hector is the coordinator of all this MIoT research, teaching of the university. But unfortunately, he has some mobility issues, so he is not quite willing to travel. That's why he sent me here to present this work. And then me, yeah, I'm helping with this work. And Paul, and then our PhD. And the partner, part-time master is working on this. Yeah, so this is our teaching part related to MIoT. And besides that, we also do research, as I mentioned. The second priority is our research. Now we are working on this B5G or 6G cloud fog edge computing. And we also have this system developed, like purely software-defined 5G communication stack with edge fog cloud computing capabilities. Yeah, we have tested the latency. It's like end-to-end. It's like 10 milliseconds. So this is the one system. The other one is from another project that we recently developed. It's like we developed this anywhere station, same concept with the battery and solar panel to provide the power, but a box that could generate, that could create 5G or 6G cellular network. And for that part, the UE devices, like mobile and 5G sensor, they can connect here and then go through satellite, go back to the core network. So getting rid of the limitation of the power grid and also the terrestrial network. So this one we are going to install in a farm in Malaga by the end of this month. Yeah. Yeah, so for the research part, if we have a chance next year, maybe we're going to present more to provide more detailed information. Yeah. So yeah, that's all for my sharing today. And welcome to San Sebastian if you have time. Yeah.